displaced. From the day we are born, we start exploring.
We find out that water takes the shape of a bathtub. Water moves when we're in it, or when we splash with our toys. Whether the toy floats or sinks, it doesn't matter. Everything that goes in the bathtub makes the water level rise. But the same is true for any fluid, not just in a bathtub. As these drag boats speed towards the finish line, they're actually raising the water level in the lake. Fluids change shape when something pushes on them. We say that it's being displaced.
The force of this object is its weight. You know, if I drop it loop on the table, it's got a force, okay? So if I drop it in the water, the force or the momentum of that object is enough to literally push the molecules of water out of the way.
Everything takes up space, but not the same space. If the hippo wasn't swimming, water would be in its place. If this balloon wasn't here, cool air would fill its space. But as it is, both the hippo and the balloon are displacing fluid. The question we need to ask now is, how much fluid is being displaced by these objects? Scientists call the space an object takes up its volume. For example, the volume of this container is 1 liter. It's simply a cube, measuring 10 centimeters on all sides. By multiplying the length, width, and height, we can find out the cube's volume. 10 centimeters times 10 centimeters times 10 centimeters equals 1,000 centimeters cubed. It's also called 1 liter. Inside the cube now is 1 liter of air. But if I pour a liter of water into this container, the air will be pushed out. We say it's displaced. This happens because two things can't be in the same place at the same time. Measuring the volume of a cube is pretty easy, but most things are oddly shaped. Think about all the curves that make up a hot air balloon, or the bottom of a canoe, the body of a fish, or a person. The volume of these things would be nearly impossible to find with just a ruler. In ancient Greece, Archimedes was able to figure out a way to measure the volume of just about anything, regardless of its shape. It's the 3rd century BC. Hero II, king of Syracuse, has called for the royal goldsmith to take on a very special assignment. I want you to make a crown worthy of the king. Namely, me.
Yes, sire. It would be my honor.
Here is the amount of gold I will give you for the crown. See to it that all the gold is used.
Yes, sire. I can't wait to take this gold into town.
What did you say?
Oh, I said, I can't wait to make this gold into your crown.
When the new crown arrived, King Hero felt that something was wrong, and went to find Archimedes. He was a man who could solve many problems, but most of all, could be trusted by the king.
Archimedes, I have a job for you. I need to know if I've been cheated in the making of this crown.
Yes, sire. I won't do anything until I find the answers you need.
In the vaults, he found an identical chunk of gold.
Foist, let's see if they weigh the same.
Sure enough, the crown and the chunk of gold were the same weight. But something still didn't feel right about the crown.
A crown this size should be heavier than this. But how do I prove it?
Archimedes thought, and thought, and thought some more. The days went by in his workshop, thinking day after day after day, and soon he began to stink. His servants drug him off to the bathhouse. And as he got into the water, he noticed that the water level rose.
Eureka!
Forgetting his robe, Archimedes ran down the streets of Syracuse back to his workshop. He took the chunk of gold, submerged it in a tank, and measured the displaced water level. He did the same for the crown. The crown displaced more water than it should have if it were solid gold. Remember, they had the same mass, but they ended up with different volumes. They could not both be solid gold. We use this same technique to determine the volume of objects. The water level will rise by the same volume as the object. When this toy is submerged, it raises the water level. A little subtraction tells us that the toy has a volume of almost 30 milliliters. Displacement sounds like it should be an easy concept to master, but every Thanksgiving, many people lose their possessions because they don't think about Archimedes' principle.
We've recently tested several models of deep-fat turkey fryers and find that this method of cooking can be very hazardous. Looks like our partially frozen turkey is ready. The temperature's at 350 degrees, so put the turkey in. Units can be overfilled, and when that happens and a turkey is added, the oil spills out, causing the unit to catch on fire. If you overfill a deep-fat turkey fryer and add a turkey, the oil can spill over the side and ignite, causing a severe fire hazard. We hope everyone thinks twice before using a deep-fat turkey fryer, but if they do, they should exercise extreme caution. Always use these units outdoors, never on a wooden patio or in a garage. They should always be placed on a flat, level surface and never should be left unattended.
So what do we need to know about displacement? It boils down to the fact that no two things can be in the same place at the same time. The amount of fluid pushed aside will equal the volume of the object. It's also good to know that Archimedes discovered the relationship between mass and volume.